Welcome all. Today we're going to take a look at lunar eclipses. My hope is that when this concludes, you'll know what a lunar eclipse is, why they occur, and also what each of the three types of lunar eclipses are, and why we receive, or could see, I should say, three different types of lunar eclipses. So let's jump in. This picture should look kind of familiar, right? If you're not familiar with those phases, or you know what waxing crescent or waning gibbous is, or the order that those would go in, or why they occur, now might be a good time to go back and review your lunar phases notes. Because today we're just looking at lunar eclipses. And what a lunar eclipse is, you remember lunar from the Latin word luna, which means moon. And an eclipse is just to block light. So this would be when the moon's light's blocked. And the only way that can occur is going to be when the moon passes through the Earth's shadow. So shadows don't do crazy bends or something, right? I mean, you know, if I'm standing in front of a light, I know my shadow is going to be behind me. Guess you could make an argument if I turn around, it'd be at my back. But we know that things have to line up a certain way for a shadow to fall on something. And the only way you can get a lunar eclipse is when, again, the Earth's shadow falls on the moon. So if you're looking at the little picture here, this shows that we've got the moon in all its phases. The left side of the moon is illuminated, right, in all of these phases. As it makes its way around the Earth, we see different portions of that illuminated half. That's all well and good. In order to see a lunar eclipse, the only way that you could have the sun and then the Earth and then the moon line up would be during a full moon phase. Now, if we think about that, it should kind of make sense. And some of you might be thinking, well, Cash, what about in a new moon phase? Where if I've got the sun, the moon, and then the Earth, could the moon shadow fall onto the Earth? Indeed it could, but that'd be a solar eclipse, and we're not talking about those today. So lunar eclipses can occur during a full moon. That's the only way that you would have everything line up to where the Earth shadow could fall on the moon. Or maybe another way of thinking of that is the moon passed through the Earth's shadow. So I know that lunar phases, 29.5 days, about a month. A question that pops up then is, well, how come we don't have a lunar eclipse every full moon? Good question. And hopefully this picture here sheds a little bit of light on that. If you notice this little circle here that's at a tilt, that's representing the moon's orbit or its path around the Earth, and it is at a tilt. To be more specific, it's exaggerated here, but it's going to be a tilt of 5 degrees. So what that means is you don't have an eclipse every new moon or every full moon. Because the way that it shakes out is you usually have the new moon or a full moon a little bit too high or a little bit too low, and the shadows are just cast off into space and they're not falling into them. So that's why we don't have a solar eclipse every new moon and a lunar eclipse every full moon. So in that new moon phase, which like I said we'll look at with solar eclipse parts, that would be, well, does the moon shadow fall on the Earth? And we're looking at the lunar eclipses. Well, how come there's times that we could have full moon, but that doesn't pass through the Earth's shadow? And again, the reason being is the moon's orbit's at a tilt. To be more specific, it's a tilt of 5 degrees. So there are times that the full moon lines up where the shadow does fall on, where the Earth's shadow does fall on the moon. And the place where the moon crosses the ecliptic, remember way back when we said the ecliptic is really just kind of a general term for orbit or path, but when the moon crosses the ecliptic, that path there, it's referred to as the line of node. And the lines of node, if you get a full moon phase there, then you're going to have an eclipse. Why doesn't it happen? Again, because a lot of times the full moon phase, the full moon is just a little bit above or a little bit below the way everything would line up, and the Earth's shadow just gets cast off into space. If the moon doesn't pass through that shadow, no eclipse occurs. So if this all works out to where you're at a new moon phase, then that would mean that you could have a solar eclipse. If it happens to where the full moon happens at the lines of node, then you can wind up with a lunar eclipse. So here's a picture that's just kind of trying to show you, if you were situated behind the sun and you were looking through the solar system to the Earth and the moon, this is just kind of trying to show you, okay, here's the ecliptic, and then here's the moon's path. So you've got spots, almost kind of like those equinox spots, right? But where the moon's either up too high or down too low. So let's say that this was a full moon, rather than it looks like we're looking at a new moon phase here. But you had a full moon and it's over here. So it goes sun, Earth, moon. And your full moon's up over here. Or your full moon's down over here. The Earth's shadow is going to line up straight. And if it doesn't pass through the lines of node, where that path or the ecliptic intersect, then you're not going to wind up with an eclipse. So here we see a lunar eclipse and a solar eclipse. Cash, lunar eclipse there. Looks kind of reddish. What's going on with your resolution? I'll explain in a second. But check out the solar eclipse. What do you suppose that little glowing orb is behind that black circle there? The sun, right? We'll get into the solar stuff later as well. But when do these occur, right? Now we know, okay, well, we're not going to get a lunar eclipse every single full moon. Check. It's got to all line up. Lines of node. Nice term, Cash. Go on with it. Okay. So how often can you expect to see a lunar eclipse? Well, you'll always get some a year. Keep in mind, though, in Michigan, we get a lot of cloudy weather, and sometimes we could have clouds that just, don't allow us to see them. But everything lines up properly at least twice a year. No more than 5 times a year. So, I don't know. I guess it's subjective, right? Is 2 to 5 times a lot or a little? I don't know. You know what I mean? It's definitely not like a once-in-a-lifetime event, though. I would say regularly, but again, that's sort of a subjective term on my own. Solar eclipses work out to be just about as frequent, and when we get the lunar eclipses and the solar eclipses and we squash it all together, you can see up to 7 eclipses, be that lunar and solar, in a given year. So, if you know when to look, you can always see them. But in a moment here, we'll talk about different types of lunar eclipses and which ones are kind of cooler than others. But right now, I just wanted to touch on the frequency. Here's a picture that I scanned in from your book. And it just shows us, okay, well, we've got the sun, the anchor of our solar system. And then this orange circle here, that's the ecliptic for the orbit of the Earth, the Earth's path around the sun. And then you've got each of these little kind of blue squares. And notice that they're tilted. That's supposed to show you the moon's orbit or the moon's path around the Earth. And it's at that 5-degree tilt. And like if you look at this top guy, look at this. Everything lines up nice and neat with that line of node. So in a new moon phase, it's possible when it occurs on that line of node for the moon shadow to fall on the Earth. Or if you get a full moon phase in that line of node, it's possible for the Earth shadow to fall on the moon. Those would be eclipses. But if we look at some of these other ones here, like this guy on the right and this guy on the lower right, are kind of like your, like 3 and 5 o'clock positions there or whatever. Notice this, that the shadows, they're cast off into space. They don't line up onto each other. No eclipse there. You have to have the new or full phase fall on that line of node, which is a fancy way of saying everything line up to where shadows fall onto something. Let's take a look at this real quick, and then we'll carry on.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
What the heck, Cash? Penumbras and umbras and all kinds of refractions. We didn't talk about any of that yet. I know, I was just laying the groundwork for the basics of a lunar eclipse. But as mentioned in the video there and shown in the picture, there's actually two parts of shadow. One's referred to as the umbra and the other's referred to as the penumbra. And basically the difference there is one is kind of like a shaded area where some light sort of sneaks in, and the other is everything, like black, dark. All direct light is blocked out. So looking at the picture here, or reading through the definitions, or listening to the video, we've got the umbra. That's a smaller, like, kind of cone here of shadow. That's going to be where, again, all the direct light's blocked out. And a larger area, but less blocked, sort of shaded again, is going to be the penumbra. Now, I'm guessing that in your day-to-day vocabulary, you don't use the terms umbra or penumbra very regularly, and some of you, it's probably the first time you'd ever heard that. Totally fine. Where I'm headed here is just like a little tip that maybe will help you keep them straight. I used to think, all right, well, there's this big weird word, penumbra, and if you look closely, in it is the word umbra. Check this out. In the penumbra is the umbra. So, you know, umbra is a smaller word in the penumbra. I used to think, well, the umbra is a smaller area inside of the penumbra. I don't know. Perhaps that'll work out for you. But if you look at this bottom part here, since we've got two parts of shadow, we can actually wind up with three different scenarios. So what's that all mean? It means that we can wind up with different types of lunar eclipses. There's actually three different types. And it's going to depend on where the moon travels through, or what part of shadow it travels through. So of those possibilities, you get a different type of eclipse. One's referred to as a penumbral eclipse. One's referred to as a partial eclipse. And the last one is referred to as a total eclipse. So again, you've got the penumbra, bigger word, bigger shadow, shaded area. And then you've got the umbra, that's going to be smaller words, smaller area, dark out. All the direct light is blocked out. And with that, you could have all the way through penumbra, all the way through umbra, or a bit of both, giving us these three options of lunar eclipses to occur. So the first one we'll look at here is the penumbral eclipse. So like the name suggests, it passes through, and by it, I mean the moon passes through just the Earth's penumbra. The full moon, you know, I mean, it makes sense, right? That's the only phase that you could have a lunar eclipse occur in, would be a full moon phase. It's going to look a little dimmer or kind of reddish. To be honest with you, if you see a penumbral eclipse, it's not that awe-inspiring. There's been times where I was just like, that's it? or if I didn't know that there was a penumbral eclipse occurring and I just looked up and saw a full moon phase, a lot of times I don't think I would even notice anything's different. Why? Well, because it's in the shaded area, and sometimes, you know, you can get a little atmospheric twinkle or some cloud cover, or just, you know, the moon happens to be at a little different lower or higher above the horizon, and you just might not really notice it. It is a type of eclipse because it does pass through a part of the Earth's shadow, but that's going to be the penumbral eclipse. Here, we see almost looks like a wonky, like lunar phase that we didn't discuss, right? This is a partial eclipse. And like the name suggests, part is in each shadow area. Part of the moon is in the umbra, and then the other part is in the penumbra. So the way this is oftentimes referred to as is like an odd lunar phase, or sometimes people will say it looks like there's like a bite taken out of the moon. But here we see again a partial eclipse. This lower area that's much darker, that's in the umbra of the Earth's shadow. And then this other area, which is less dark or less shaded, or, you know, however you want to think of it, more illuminated perhaps you could say, that's going to be passing through the Earth's penumbra, or that larger area shadow that's not as dark. So you got the third guy, right? This is the best of the bunch in Shane's, Mr. Cash's opinion. This is the total eclipse. And for the total eclipse to occur, it's going to travel completely into the umbra. But, you know, if you think about the way that the shadow's set up, you've got that larger area that's the penumbra, and then you've got that smaller area that's the umbra. It's not like the moon just disappears, shows up in the umbra, and disappears, and it's gone. It's got to slowly travel through each. So you kind of get the best of all worlds, and in my opinion, the neatest eclipse, because while it's in the penumbra only, you kind of have your penumbral eclipse. You get a chunk of time where it's actually some in the umbra, some in the penumbra, and then you get some just in the umbra, and then you get that reversal as it makes its way out, or it exits that, like, you know, eclipse phase or from the shadow. So the whole shebang-a-bang, the kit and caboodle, the grand total eclipse, you know, it can last for up to almost 2 hours, more specifically, an hour and 47 minutes. So this isn't like a blink of an eye. We'll see, like with the solar eclipses that happen much faster, because the moon's shadow is a lot smaller and the Earth's a lot bigger. We'll get into that later. They're a lot faster. But, you know, a lunar eclipse, I mean, sheesh, that's enough time to go inside, grab a snack, come back out, and go check out some more, right? Notice here, in this center, where the moon has reached totality, it does not completely disappear. It's got that reddish color like we'd sort of seen before and was discussed in the video. Why does that happen? Well, if you paid attention to the little video there, you'd know. It turns out that even though we said the umbra is the dark, completely direct light blocked out area, the Earth has an atmosphere around it, and that atmosphere bends some light. So you wind up with some light that gets bent, or the fancy word for that is refraction. Some light gets refracted, means bent, onto the moon. And since it's getting bent, it sort of slows that light. And you might remember from way back when we looked at the electromagnetic spectrum, visible light, that little sliver of the electromagnetic spectrum, that visible light, the Roy G. Biv, the, you know, red, orange, yellow, green, the visible light spectrum, as it gets slowed, the red is the slower side. It makes its way through, and it can bend and fall onto the moon. So since you get the red frequencies of visible light that get refracted or bent onto the moon, it's got a reddish dark color. This used to be scary to the ancients because they thought that the moon was angry, or a dragon was spilling blood, or depending on what story you buy into. But today we're pretty certain that it doesn't have anything to do with that, but just, you know, light refraction. So check that out though, right? Here, top full moon phase here, this would actually be a penumbral eclipse because it's just in the penumbra. Looks dimmer, right? Maybe a little reddish tinge to it or something. Then we start to see a partial eclipse occur because parts in the penumbra as part moves into the umbra. And then once it gets completely into the umbra or totally into the umbra, you've got a total lunar eclipse. And this reddish hue, sometimes people refer to it as like a rust-like color. I think it's got like a darkish reddish color there. And then as it starts to make its way out, it reverses. Kind of like, the lunar phase is sort of kind of in that cycle. But this isn't a monthly occurrence, only when the full moon falls on that line of node. So here, didn't turn out so great, right? They were the last lunar eclipse that I tried to snap some photos with for this. But fear not, the internet is a wealth of information and people with much better photography than myself. Let's take a look at one of these guys occur. All right, so this is a while ago, but it doesn't matter. Notice how it changes. So we went from a penumbral to a partial. Cash, why is that getting dark over there? It's like a weird reverse, like lunar phase or something. Well, it's because the moon's entering the umbra while some is in the penumbra. So this would be like a partial eclipse, right? What do you think will happen to the moon once we reach the umbra or totality? Baboon, as predicted, right? You get that awesome darkish reddish color. Then it starts to make its way back out of the umbra. So we're going to kind of get those partial eclipses again until eventually it's just in the penumbral eclipse, and then it just continues on about its journey off into space. Pretty nifty, huh? So if you noticed in the top left corner there was like a clock kind of giving you a wind down of when this happens. Again, that whole process, by which I mean from entering to exiting the shadow, could last up to 1 hour and 47 minutes. So it's not a extremely fast process, but again, that's subjective. So we've got reddish color that happens from refraction with totality or with total lunar eclipses. Sometimes kids will ask, like, well, it's kind of like sunrises, sunset colors, those reds and oranges. That's true. Why do you suppose we get reds and yellows during sunrise and sunset, but not during the day? I mean, it's still the same sun, still cut through the same atmosphere. And the reason being is, well, how much of that atmosphere does the sunlight have to travel through? As it's just popping up above the horizon or below the horizon, sunrise or sunset, it's got a lot more atmosphere to cut through. Consequently, slows some of those lights. And the reds and the oranges, the slower side of that visible light spectrum, that's what falls on our eyes. And we get those, in my opinion, nice looking sunrises and sunsets. Do you suppose sunrises and sunsets would look like that on the moon? Well, here's a hint. What causes the oranges and the reds? Some of you are probably thinking, well, sunlight. No. Wasn't the sunlight. What is it about the Earth that causes those reds and oranges? Our atmosphere, right? That sunlight passes through the atmosphere and that sort of bends the light or refracts the light to where we just see those reds and oranges and kind of yellows. So does the moon have an atmosphere? No, it does not. So would sunrise and sunset be oranges and reds and, sometimes pinks and purples? No, it would not. It'd just be sun on or sun off because it lacks an atmosphere. Who the heck gets to see these lunar eclipses when they occur? Turns out everybody. I mean, by everybody, I mean if it's the half of the Earth that you're facing the moon during the full moon phase, you get to see it. The other half, they cannot because they would be facing off into the wrong direction of space. But with the solar eclipses, what you're going to find is there's real small bands of places on Earth that actually get to see a solar eclipse. The rest of the Earth would have no clue that those are actually occurring, or at least they wouldn't visibly be able to observe it. Look at this guy. Bit of review. That's the line that separates light from dark. It's referred to as the terminator. And if you remember, you look at the Terminator, if you're looking at the moon, and you get the best detail. It's kind of like where you get a nice blend of light and dark colors, so you see most of the detail. It's not washed out with bright white or just too dark to really be able to see those finer details of the moon's surface. So here's some review, right? I mean, this should kind of make sense. On the left, that's the rundown of what has to happen to actually get an eclipse, be it lunar or solar. That means you're either going to have a full moon on the line of node to get a lunar eclipse, or a new moon on the line of node to get a solar eclipse. And that should make sense, and it explains why we don't see them every full or every new moon. If you take a look at this picture on the right, we've got our different parts of shadow, the larger penumbra, the shaded area, and the smaller, more blocked out area, the umbra. And that gives the moon really three options of what it could travel through, right? Look at the bottom of the right pic there. It could pass just through the penumbra, giving you a penumbral eclipse. It's going to look dimmer, maybe a little reddish. In my opinion, not too spectacular. You could have the moon pass through both, kind of just skim through like you see in that 2 or the middle guy there to get a partial eclipse. And that's going to be when part is in the umbra and part in the penumbra, hence the term partial eclipse. Or you could have the moon pass through and go completely into the Earth's umbra. And while it's in there, we reach totality, and that's where it gets that dark reddish color because some refracted light still sneaks through. But if you look at the path there, like I said, in that total eclipse, you kind of get all of them, right? I mean, there's a chunk that's in the, or excuse me, a time when it's just in the penumbra. You could say it's a penumbral eclipse. There's part in the total, or excuse me, in the umbra and part in the penumbra, gives you the partial. Then it dips into the umbra only, completely covered in the umbra, and that's where you get the total eclipse, and then the process reverses, taking upwards of 1 hour and 47 minutes. So hopefully that gives you some good intro to what a lunar eclipse is, little intro on the solar eclipses that we'll look at next time. And if asked, you could clear up some questions about why we don't get them every full or new moon, where things would have to line up for each to occur, and compare and contrast a penumbral, a partial, and a total lunar eclipse. If you've got questions, please seek me out. I'll be happy to clear things up for you. Till we meet again, take care.